Okay, for my relevance of question and topic explained for Newton's third law of motion, I chose to make the question up. A 65-kilogram skateboarder pushes backward on a wall with a force of 180 newtons. According to Newton's third law of motion, what force does the wall exert on the skateboarder and in what direction? And explain your reasoning. I picked this question because it directly relates to Newton's third law because it focuses primarily on the action and reaction force pairs. And understanding this law helps to explain how the objects interact whenever a force is applied, specifically the skateboard and the wall. Learning to solve this type of problem helps us recognize that forces always come in equal and opposite pairs and that they're not just by themselves. Also, like a picture of the pendulum to kind of prove that. This concept applies to everyday situations like walking, swimming, running, driving, etc. I created this problem by choosing a common realistic situation involving a skateboarder pushing along the wall. We also had a lot of skateboarding stuff brought up in my house at the time, so it was easy to kind of think of something. By including the mass and applied force, there's enough information to analyze the action-reaction forces without making the problem too simple, while also keeping it simple enough to solve, because I know stuff like this can be a little difficult, so I figured making it semi-simple would help. It also made it easier for me to be able to know, like, okay, I could help you, I know exactly what I'm talking about. The uniqueness makes the problem uses a skateboard on a wall as opposed to like a rocket or a balloon or a swimming example, which a lot of the ones where I was trying to find inspiration had. Newton's third law and uses Newton's third law in a practical situation, making it really easy to visualize. I was able to draw it out and everything, so it made it a lot easier to figure it out. I had something make a picture for me because my artwork was not very pretty, but this is the relevant chart or graph or diagram. The relevant formulas and constants explained. Newton's third law: for every action force there's an equal and opposite reaction force. The formula was FAB equals FAB. The force is measured in newtons, which is the capital N that you should see when you're solving it. For the action and reaction forces are equal in magnitude, opposite in direction, and act on completely different objects, so it makes it easier to visualize. To solve this, I went into a lot of detail. To solve this problem, you need to identify the interactive objects, so it's the skateboarder and the wall, and according to Newton's third law, whenever one object pushes on another, the second object pushes back with the equal force, but in the opposite direction. Next, you should identify the information, and the problem says that the skateboarder pushes on a wall with a force of 180. That's the action force. Then applies Newton's third law, and every action has an equal and opposite reaction. The reaction force is the same magnitude, 180, but it acts in the opposite direction. The reaction force acts on the skateboard, not on the wall, which, if you were to kind of do it backwards, I could see how you'd think it was the wall. After this, it's best to determine the direction of each force. Drawing it out helps. I put on there that I had to. It made it a lot easier drawing the little box. Finally, I would state that the force the wall exerts on the skateboarder and explain why the forces are equal and opposite based on Newton's third law. All of this ensures that the solution is based on identifying the interacting objects, recognizing the action-reaction pairs, and correctly applying Newton's third law before reaching the actual final answer. My partner put their solution that was that the wall exerts 180 force on the skateboarder opposite direction of the skateboarder pushed on the wall. The reasoning was that Newton's third law states that the force always comes in action-reaction pairs, and these forces have equal magnitude, 180 each, and act in opposite directions, act on different objects, the skateboarder and the wall. Additional value information would be that the action-reaction forces are always occur in pairs. I know I've been saying it a lot, but it is important in order to actually understand this law and understand any of the problems that me or my partner made. The two forces act upon different objects. They're like my two different objects were the skateboard and the wall. The forces have no delay in between the action and reaction, so they happen at the exact same time, and they are always equal, or the forces are equal in magnitude but opposite in direction. the additional student says Newton's third law is interesting because it explains how all of my everyday activities work. So I thought it was kind of easier to understand. Understanding it helps to connect physics concepts to real life situations and technology, which as a human being I deal with and experience every day. For example, I'm using my thing to record, and I've had to use as my slideshow. The overall summary is that every action has an equal and opposite reaction. The action and reaction forces act on different objects, which is very important as I learned throughout this whole course. They do not cancel each other out. These force pairs always occur at the same time and are always equal in magnitude. And it explains everyday motions such as walking, swimming, rocket launches. Oh, it's not necessarily everyday, but rocket launches and vehicle movements. And these were all of the links I used. The only thing different is that I did use for my equation, I used AI I used like my little photo of my equation to make up a slide AI like picture for me. So because my drawings weren't pretty as well.